As of the 2008 National Electrical Code, all 15 and 20 amp branch circuits in dwelling units require arc fault circuit interrupter protection. This requirement extends to 240 volt circuits as well. Generally, ground fault circuit interrupter protection is not mandated for 240 volt circuits, excluding bathroom and kitchen countertop receptacles. Considering 240 volt circuits needing arc fault circuit interrupter protection, tandem arc fault circuit interrupter breakers can be implemented. Tandem arc fault circuit interrupter breakers consist of two single-pole arc fault circuit interrupter breakers joined together. They occupy the same panel space as a regular two-pole circuit breaker, enabling protection for both ungrounded conductors in a 240 volt circuit. Regarding combination ground fault circuit interrupter and arc fault circuit interrupter breakers, several manufacturers offer them. The ground fault circuit interrupter component of these breakers usually has a 5 milliamp rating, which aligns with the standard rating for ground fault circuit interrupters. It's important to know that not every manufacturer produces these combination breakers. Also, combination breakers are generally pricier than individual arc fault circuit interrupter or ground fault circuit interrupter breakers. In many situations, opting for separate arc fault circuit interrupter and ground fault circuit interrupter breakers proves more economical. However, specific circumstances might favor using a combination breaker. For instance, a combination breaker can conserve space when panel space is limited. Arc fault circuit interrupters are designed to detect dangerous electrical arcs, which are unintended electrical discharges that can occur in a circuit. These arcs can generate significant heat and are a leading cause of electrical fires. Arc fault circuit interrupters work by monitoring the electrical current and identifying patterns that are characteristic of arc faults. When an arc fault is detected, the arc fault circuit interrupter quickly trips this circuit, cutting off the flow of electricity and preventing a fire. Ground fault circuit interrupters, on the other hand, are designed to protect against electrical shock. They work by monitoring the current flowing through a circuit and detecting any leakage current that may be flowing to ground. If a ground fault is detected, the ground fault circuit interrupter quickly trips the circuit, preventing a person from receiving an electrical shock. The 5 milliamp rating of the ground fault circuit interrupter component in combination breakers refers to the level of leakage current that will cause the breaker to trip. This level is considered safe for human contact, as it is unlikely to cause serious injury. When selecting arc fault circuit interrupters and ground fault circuit interrupters, it's crucial to choose products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertek. This ensures that the products have been tested and meet safety standards. Also, adhere to the manufacturer's instructions for installation and maintenance. Proper installation is vital for the safe and effective operation of these devices. The 2008 National Electrical Code's requirement for arc fault circuit interrupter protection in dwelling units was a significant step in enhancing electrical safety and preventing electrical fires. Arc fault circuit interrupters have proven effective in reducing the risk of electrical fires and protecting lives and property. It is important to understand the requirements of the National Electrical Code and to ensure that all electrical installations comply with these regulations. Firstly, arc fault circuit interrupters provide enhanced protection against electrical fires caused by arc faults. Secondly, ground fault circuit interrupters offer protection against electrical shock by detecting leakage current. Thirdly, combination arc fault circuit interrupter and ground fault circuit interrupter breakers provide both arc fault and ground fault protection in a single device. One should consider the advantages and disadvantages of each type of breaker before making a selection. When installing arc fault circuit interrupters and ground fault circuit interrupters, it's imperative to follow the manufacturer's instructions carefully. Also, make sure that the devices are properly grounded and that all wiring connections are secure. Routine testing of arc fault circuit interrupters and ground fault circuit interrupters is crucial to ensure that they are functioning properly. Test buttons are generally located on the devices. Pressing the test button should trip the breaker, indicating that it is working correctly. If a breaker fails to trip when the test button is pressed, it should be replaced immediately. Arc fault circuit interrupters and ground fault circuit interrupters are essential safety devices that can protect against electrical fires and electrical shock. It's crucial to understand how these devices work and to ensure that they are installed and maintained properly. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect advancements in technology and changes in safety requirements. Electricians and other electrical professionals should be familiar with the latest edition of the National Electrical Code and adhere to its requirements. The National Electrical Code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed guidelines for ensuring the safe and reliable operation of electrical systems. Complying with the National Electrical Code is essential for protecting people and property from electrical hazards. It's important to note that the National Electrical Code is not a law. However, it is widely adopted by state and local governments as a basis for their electrical codes. This means that electrical installations must comply with the National Electrical Code in order to be approved by local authorities. In addition to the National Electrical Code, there may be other applicable codes and standards that must be followed. These may include local building codes, fire codes, and energy codes. It's important to be aware of all applicable codes and standards before beginning any electrical work. Electrical work can be dangerous, and it's important to take precautions to protect yourself from electrical shock and other hazards. Always disconnect power before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not qualified to perform electrical work, it's best to hire a licensed electrician. A licensed electrician has the training and experience necessary to perform electrical work safely and correctly. Choosing a qualified electrician can help to ensure that your electrical system is safe and reliable. In addition to installing and maintaining electrical systems, electricians can also provide advice on energy efficiency and other electrical-related issues. They can help you to choose energy-efficient appliances and lighting fixtures, and they can also provide guidance on how to reduce your energy consumption. By following the advice of a qualified electrician, you can save money on your energy bills and reduce your environmental impact. Electrical safety is a critical concern, and it's important to take steps to protect yourself and your family from electrical hazards. By understanding the requirements of the National Electrical Code and by working with qualified electrical professionals, you can help to ensure that your electrical system is safe and reliable. It is advisable to consult with a qualified electrician for any electrical work, especially when dealing with arc fault circuit interrupters and ground fault circuit interrupters. They can provide expert advice on the selection, installation, and maintenance of these devices. Electrical panels should be properly labeled to clearly identify the circuits they control. This helps to prevent confusion and ensures that the correct circuit is de-energized when performing electrical work. Regularly inspect electrical cords and appliances for damage. Replace any damaged cords or appliances to prevent electrical shock and fires. Avoid overloading electrical outlets and circuits. Overloading can cause the wiring to overheat and potentially lead to a fire. Use power strips with surge protection to protect electronic equipment from power surges. Power surges can damage sensitive electronic components and shorten the lifespan of your equipment. Keep electrical appliances away from water to prevent electrical shock. Never use electrical appliances in or near bathtubs, showers, or swimming pools. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical hazards. Supervise children when they are near electrical outlets and appliances. If you experience any electrical problems, such as flickering lights or sparking outlets, contact a qualified electrician immediately. Do not attempt to repair electrical problems yourself unless you are a qualified electrician. By following these safety tips, you can help to prevent electrical accidents and protect yourself and your family from electrical hazards. Always remember that electricity is a powerful force and it should be treated with respect. Stay informed about the latest electrical safety information and recommendations. The Electrical Safety Foundation International and other organizations offer resources and tips on electrical safety. Take advantage of these resources to stay up to date on the latest electrical safety practices. Consider taking a course on electrical safety. Many organizations offer courses on electrical safety for homeowners and other individuals. These courses can provide valuable information on how to prevent electrical accidents and protect yourself from electrical hazards. Electrical safety is an ongoing process. It's important to be vigilant and to take steps to protect yourself from electrical hazards every day. By making electrical safety a priority, you can help to create a safer home and community. The requirements for arc fault circuit interrupters and ground fault circuit interrupters can vary depending on the specific application and local codes. It's important to consult with a qualified electrician or electrical inspector to determine the specific requirements for your situation. They can provide expert guidance and ensure that your electrical system complies with all applicable codes and standards. The technology behind arc fault circuit interrupters and ground fault circuit interrupters is constantly evolving. New and improved devices are being developed all the time. Stay informed about the latest advancements in arc fault circuit interrupter and ground fault circuit interrupter technology to ensure that you are using the most effective safety devices available. The use of arc fault circuit interrupters and ground fault circuit interrupters is a crucial aspect of modern electrical safety practices. These devices play a vital role in preventing electrical fires and electrical shock, protecting lives and property. By understanding the principles behind these technologies and by adhering to the relevant codes and standards, one can contribute to a safer electrical environment.